All right, this video is to help you review and prepare for the graphing equations retake test. All right, so what we're going to do is basically I've just picked out a few problems on the review to go over with you. The rest of those will be for you to do on your own, so you might want to have your review out in front of you as you step through this video, and you'll get some of the answers then for your video. I'm going to go ahead and zoom in a little bit here. So this problem here is the first one we're going to look at. It's actually like the second one on your worksheet, though. All right, our directions say to identify the x and y intercepts of the graph. X and y intercepts are where the lines cross the axis. So I see here that on my x-axis, this line touches the x-axis at 6. So my x-intercept is 6, and my y-intercept crosses here up 3, so that is positive 3. If it were below down here, it would be negative, or if it was over here to the left, my x would have been negative. Okay, but my intercepts, again, are where we touch the x and the y axis. All right, then on this problem down here, so I'm shifting down a little bit, so it's not, our directions now are to graph with intercepts, so I'm going to look at the second problem here of that one. Graphing with intercepts is where I use the cover-up method. Okay, basically we're creating two little equations that help us find the x and the y-intercept. So the first equation, I'm going to cover up the y term completely, and I see I have the new equation, x equals 6. I actually don't need to even solve anything here. That actually is my x-intercept. All right, now to find my y-intercept, I cover up the x term, and I'm careful not to cover up that negative sign in front of the 3. My new equation that I see is negative 3y equals 6. Okay, to solve for y here, I need to divide both sides by negative 3, so I get that y equals negative 2. That's my y-intercept. And as we just discussed, the x-intercept is where we touch the x-axis, so right here at positive 6. And the y-intercept is where we touch the y-axis. So that's going to be down 2 at negative 2. Then I can just graph my line. Your school ID is a great thing to use to like make a nice perfect straight line, but I'll use this little ruler. Okay, and I'm going to make a line that goes all the way across my graph, and I'm going to put arrows on the end. Okay, so find your two intercepts, and then plot those on the x and the y-axis to make your line. All right, we're going to jump over to kind of the next page for you. It's just to the right-hand side on your sheet. Okay, up at these top three problems, it says just to find the slope of each line. So really this whole page, all we're doing is finding the slope of each line. So we're given different things. When we're finding slope from a graph, we're thinking of slope as rise over run. All right, so we find two good ordered pairs, and this is where we make our little triangle. All right, I see that I go over 1, 2, 3, 4. All right, and I go down 1, 2, 3, 4, 5, 6. All right, the thing that I have to notice here and keep in mind is it's a downhill line, which means I'm sure my slope is going to be negative. So no matter what the numbers are, I know my slope is a negative slope. And then rise over run, my rise is this up and down number. My run is the side to side. So my slope is 6 over 4. And I can reduce that. If you type that in a calculator to reduce it, this is the same as negative 3 over 2. Okay, so my slope for this line is negative 3 over 2, rise over run. All right, we're going to go to the one just below that. I have two ordered pairs. When we have two ordered pairs, we actually turn them into a table of values like we see over here. So this problem, you ought to be able to do the table of values problem after we do this problem here. So I'm going to turn this into a little table of values, x and y, and I'm going to take my two ordered pairs, x, y, and x, y. So 12, negative 18 is my first ordered pair, my first x, y combination. My second one is negative 18. Sorry, not negative 18 now. Let me just erase that real quick. Negative 18 we just used as our y value, and it is a y value. My other ordered pair, is 11, 12. So 11 and 12. And now what we look at each time, instead of rise over run like we looked at with the graph, we look at the change in y. Okay, and sometimes we refer to that as delta y. Okay, change in y divided by the change in x. Okay, so we have to figure out how much this is changing on each side. If I'm at negative 18 and I'm going all the way to positive 12, sometimes that can be a little tricky to figure out how far that is. If you want to type this in a calculator, what you want to do is type the bottom number minus the top number. So 12 minus negative 18 is what you would type in a calculator right there. If you did that, what you would find is this side is 30, actually positive plus 30. Okay, if you wanted to type this in the calculator over here, you would type 11 minus 12. and we find that that is -1, okay? And if we think about it, going from 12 to 11, we're just subtracting 1. Okay, so then to find my slope, I do the change in y, this y side, divided by the change in x. So 30 divided by -1, okay? And if I were to type that in a calculator, or if I just think about positive divided by negative, this comes out to be a -30 for the slope. So now you ought to be able to apply that same idea, change in y to change in x, back to this table of values problem. All right, when we're given equations of lines like we are down here at the bottom, so these are the bottom left two problems here on this part of your paper, what we're looking for is the value that's attached to x when y is by itself. So when, in this situation, y is all alone, here's my x, I'm looking for the coefficient or the number that's attached to that x. So this one's really easy. The slope is -1/5. It's that number attached to x when y is all alone. Now this one down here is a little bit trickier. Y is not by itself. So we have to get y all by itself before we can identify the slope. All right, so to get y by itself here, first I have to move my x term. So I'm going to do a -5x to each side. So 2y equals, and these aren't like terms here, so I can't combine them. So I just list out -5x plus 6. Okay. Now I still don't have y by itself. I have to divide everything by 2. And so I'm going to kind of ignore this m equals line for right now. I end up with y equals, and -5 divided by 2 doesn't really come out to anything nice, so I'm just going to leave it, -5/2x. And then I also have to divide the 6 by 2. 6 divided by 2 is 3. So here's my equation where y is now by itself. Okay, so I look at the number attached to x, and I see that my slope, and I'm just going to ignore this here, I'll put it down below. I see my slope, m, equals -5/2. Okay, slope is always just a number. Notice that we didn't put any x's or y's or anything like that when we were answering these questions. Slope is always just a number. All right, now flipping your page over, we're going to take a look at a couple problems where we're graphing now with the slope and the y-intercept. Okay, so my slope on this problem, again, like we just said, the slope is the number attached to x when y is alone. So the slope is 1/5. And the y-intercept, we use the letters m and b to represent this. So b, the y-intercept, is -4. It's that other number when y is by itself. The way we graph these, we always start or begin with b, the y-intercept. So I'm going to put this y-intercept on the y-axis. So here's my y-axis. Here's -4. All right, and then I use my slope like rise over run. So rise 1, run 5. From this dot that I've already made, I rise 1 and I run 5 and I put another dot. Okay, once I have 2 dots, then I can make a good line for my graph. All right, by connecting those 2 dots, making it go all the way across the graph and put arrows on the ends. Okay, so always start with the y-intercept, then use the slope. All right, let's try one more of those. Okay, again, y is already by itself. Okay, so I see that my slope is -7 and my y-intercept is 3. Okay, begin with the y-intercept. So go up to 3 and put a dot. And then our slope this time is not set up as a fraction like rise over run. So we need to turn it into a fraction. Anytime it's a whole number like this, we can just put over 1. So again, rise over run. Okay, this time though, if I'm going to rise -7, I'm going to go down 7. Okay, so 1, 2, 3, 4, 5, 6, 7. And then I'm just going to run 1, which is to the right 1. Okay? And something to always double check is when you have a negative slope, after you graph that negative slope, do you end up with a nice negative line like you would expect right here? And we see that we do end up with that negative line. All right, so all the problems in this area are continuing that same idea of graphing with the slope and the y-intercept. Just make sure that when the slope number is positive, you have an uphill line. When the slope number is negative, you have a downhill line. Okay, so you should be able to complete the problems in that area. We're going to look at the very bottom of this page, graphing some special lines. In these problems, we see we have y equals and x equals, but we only have one variable in each equation. Anytime you have both variables, like up here at the top, we have x and y in both of these that we just did, our lines are going to be slanted. All right, when we have just x or just y, this is when we have horizontal and vertical lines. So what I'm going to do here, y equals -3. I'm going to go down 3, 1, 2, 3, so that I'm at y equals -3. This is my y-axis right here. Okay, so y equals -3. Well, I'm going to draw my line horizontally. Okay, so it's whatever letter is in the equation is the axis that we cut through. Okay, so every point on this line, y equals -3. Okay, when it's x equals, we do the same thing, but we just use the x-axis. So I'm going to go to where x equals 1, which is right 1. Okay, and now instead of a horizontal line, I'm going to draw a vertical line. And these are all of the places where x equals 1. All right, this last page, last section of your review are actually a little bit like kind of trickier problems, type 2s, type 3s. Work through those, talk to your teacher if you have any questions on those, but we're not going to work through any of those on the video. So these are problems that you should still be able to do, but sometimes you kind of need to think on those a little bit and work a little harder on those. So talk to your teacher if there's anything that's still confusing.